Quarter 4, test number 1 review, sections 8.1 to 8.8 solutions. So if we look at example 1 in section 8.1, we're rewriting the expression using radicals. So remember that denominator in our exponent is our index, and then the numerator is our power. So this is going to be the cube root of 7 to the 4th power. And then you can also write this as the cube root of 7 to the 4th power like this as well. Totally up to you which way you want to write it. I prefer the first. For 2, we have 3 to the power of 2 over 5, so the 2 is our power, the 5 is our index. So this is going to be the 5th root of 3 squared. For number 3, we have 18 to the power of negative 3 over 2, so in order to turn that positive, or that negative to a positive, we're going to do 1 over 18 to the 3 over 2. So this means that we're going to take the square root of the 18 and raise it to the 3rd power, keep it under 1. So it's 1 over 8, the square root of 18 cubed. For 4, 12 to the negative 1/3, turning that negative 1/3 to a positive 1/3 by taking 1 over 12 to the 1/3. And this is just 1 over the cube root of 12. For our second part here, we're finding the indicated square root. So if we look at number 5, we have a negative square root of 324. Keep the negative with your answer and factor out the 324. We know that 4 goes into it 81 times. The 4 is 2 and 2. The 81 is 9 and 9. So 2 times 9, put the negative in front of it, gives us negative 18. For 6, we have 3,500 underneath that radical, so we can break this down to be 35 and 100. The 100 is 10 and 10. We have 2 10s, so we're going to bring that 10 out. That 35 is just 5 and 7. They don't pair up with another 5 or another 7, so it's going to be 10 square root 35. For 7, we have plus or minus the square root of 54 over 24, so 54 is 6 and 9, the 9 is 3 and 3, the 6 is 2 and 3, so 2 3's, keep the plus or minus out in front, that's 3 square root 2, or sorry, 3 square root 6. This 24 is 4 and 6, the 4 is 2 and 2, the 6 is 2 and 3, so it's just 2 square root 6. Now from here, those square roots of 6 cancel out, so we just have plus or minus 3 over 2. For 8, we have the square root of 63 over 81. The square root of that 63. 63 is 7 and 9. The 9 is 3 and 3, so that's 3 square root 7. And then the 81 is 9 and 9, so that's just a 9. So 3 square root 7 over 9, the 3 and the 7 simplify to be 1 and 3, so it's just the square root of 7 over 3. For 9, we have 8 times the square root of 108. If we don't know off the top of our head what that square root of 108 is, we can divide it by 2. That's going to be 54. The 54 is 2 and 27. The 27 is 3 and 9. 9 is 3 and 3. So 2 2's, 2 3's, that's 6 square root 3. Remember, multiply it by the 8. So 8 times 6 is 48 square root 3. For 10, we have the square root of 225, x to the 4th, y to the 6th, z to the 10th. So the 225 is 5 and 45. Let's do that as a 4, not a 9. 45. The 45 is 5 and 9. The 9 is 3 and 3. So 5 times 3 is 15. We're going to divide that 4 by 2 to get x squared. The 6 divides by 2 to get y to the 3rd. And the 10 divides by 2 to get z to the 5th. So 15x squared y cubed z to the 5th. For 11, we have the square root of 36x cubed over the square root of 16. So this is going to give us a 6x square root x over 4. The 6 and the 4 simplify to be 3 and 2. So this is going to give us 3x square root x all over 2. Remember, anything that's left over after we divide, that's what stays underneath that radical, which is why we have that x that's staying underneath there. For 12 and 13, we're finding the missing side length for the right triangle. So we know that our Pythagorean theorem is a squared plus b squared is equal to c squared. So we're going to use 6 for a, b is 14, and c we're finding. So we're going to do 6 squared plus 14 squared is equal to c squared. The 6 squared is 36. The 14 squared is 196. So we have 36 plus 196, which gives us 232. So 232 is equal to c squared. We take the square root of both sides. The 232 is 2 and 1, 1, 6. The 116 is 2 and 58. The 58 is 2 and 29. So that's 2 square root 58. So c is equal to 2 square root 58. For 13, we have a is 9, b is something, and c is 20. So it's going to be 9 squared plus b squared is equal to 20 squared. And 9 squared is 81 plus b squared is equal to 400. We subtract 81 from each side. Then we get b squared is equal to 400 minus 81 gives us 400 minus 81 is 319. We can take the square root of the 319 here to get what b is, and b is just going to equal the square root of 319 because we cannot simplify that. For our set of examples, we are telling if the given side lengths form a right triangle. So if we do this, we can do a squared plus b squared is equal to c squared, and we should get a true statement. Remember, your c is always your longest side length. So in this case, the 5 is the c, and the 3 and the 4 are your a and your b. So this is going to give us 3 squared plus 4 squared is equal to 5 squared. So if we do the 3 squared, we get 9, the 4 squared is 16, the 5 squared is 25. If we add the 9 and the 16, we get 25 is equal to 25. This is a true statement, so we have a right triangle. For 15, we have 6, 7, and 9. So we're going to do 6 squared plus 7 squared is equal to 9 squared. So 36 plus 49 is equal to 81. The 36 plus 49 is 85. And 85 is not equal to 81, so this is not a right triangle. For 16, we are simplifying these. So we have 8 square root 3 times 6 square root 12. This is going to give us 8 times 6, which is 48. Square root 3 times 12, which is 36. The square root of 36 is 6. So it's 48 times 6, which gives us 288. For 17, we have a negative 7 square root 5 times 3 square root 7. So negative 7 times 3 is negative 21. The square root of 5 times the square root of 7 is the square root of 35. So negative 21 square root of 35. Again, if you could simplify that square root, you would, but in this case, the 35 only has factors of 5 and 7, which do not pair up with another 5 or another 7. So it's going to stay the square root of 35. For 18, we have 2x square root 3 times 5y squared square root x. So we are going to do the 2x times 5y squared to get 10xy squared. And then the 3 and the x underneath the radical is going to give us the square root of 3x. So it's just 10xy squared square root 3x. For our next one, we have, here we go, negative 48x to the 5th square root 6x to the 5th times negative 1/8 x square root x to the 5th. So we're going to multiply the negative 48 times the negative 1/8 to give us a positive 6 x to the 5th square root 6 x to the 10th. So we're going to simplify this square root 6x to the 10th. We're going to divide the 10 by 2 to give us x to the 5th. So it's going to be 6x to the 5th times x to the 5th times the square root of 6. So So this is going to leave us with a final answer of 6x to the 10th square root 6. For 20, we have 2x to the second power square root 5y cubed times negative 3/4 15x to the third power, sorry. So the 12 times the negative 3/4 is going to give us a negative. The 4 turns into a 1, the 12 turns into a 3, so 3 times negative 3 is negative 9x squared. Square root 5 times 15. Remember, we can rewrite this as 5 times 5 times 3 because the 15 is factors of 5 and 3. And then we have the x cubed and the y cubed underneath as well. So we're going to pair up those 5s. That's going to come out. So negative 9x squared times 5. The x divides by 2. Y cubed divides by 2. So it's going to be xy. The 3, the x, and the leftover y all stay underneath the radical. So simplifying this even further gives us negative 45x cubed y square root 3xy. Remember, when we are multiplying variables, we add their exponents. For 21, we have 6 square root 2 minus 8 square root 6 plus 9 square root 2. So like terms here are the 6 square root 2 and the 9 square root 2. 6 plus 9 is 15. Square root 2 minus 8 square root 6. For 22, we have the square root of 5 plus 3 square root 7 plus 5 square root 7. So the 3 square root 7 plus 5 square root 7 add up to give us like terms. So it's just going to be the square root of 5 plus 8 square root 7. For our next one, we have 15 square root 24 minus 12 square root 48. So we're just simplifying this. The 24 is 4 and 6. 4 is 2 and 2. 6 is 2 and 3. So this is going to be 15 times 2 square root 6. The 48 is 6 and 8. The 6 is 2 and 3. The 8 is 2 and 4. The 4 is 2 and 2. So 2 times 2 square root 3. So this is minus 12 times 4 square root 3. If we simplify this further, 15 times 2 is 30. Keep the square root of 6. Minus the 12 times 4 is 48. Keep the square root of 3. These are not like terms, so that is our final answer. For 24, we have 5 square root 45. The 45 is 5 and 9. 9 is 3 and 3. Minus 3 square root 125. The 125 is 5 and 25. 25 is 5 and 5. So we pair up our sets of 2 here. So this is going to become 5 times 3 square root 5 minus 3 times 5 square root 5. So 5 times 3 square root 5 is 15 square root 5. Negative 3 times 5 square root 5 is negative 15 square root 5. So we have opposites here, so it's just 0. For 25, we have 4 minus the square root of 12 times 4 plus the square root of 12. We can tell that this is a difference of squares here. So our A is 4, our B is the square root of 12. We can then use A squared minus B squared. So this is going to give us 4 squared minus the square root of 12 squared. 4 squared is 16. The square root of 12 squared is just 12. 16 minus 12 is going to give us 4 for our solution. If you didn't want to do it this way and you just wanted to FOIL, you can do that as well. If we look at 26, we have 7 minus the square root of 13 squared. So remember, this is the same thing as 7 minus the square root of 13 times 7 minus the square root of 13. And again, if you just wanted to FOIL, you could. If not, you can use a squared. There's a minus there, so it would be a squared minus 2ab plus b squared. You can use that, or again, you can FOIL. If you were to use that, a squared minus 2ab plus b squared, your a is the 7, your b is the square root of 13. All of your signs are already in your formula, so you can just plug it in and simplify. So if a is 7, that would be 7 squared minus 2 times 7 times the square root of 13 plus the square root of 13 squared. So this is going to give us 49 minus 14 square root 13 plus the square root of 13 squared is just 13. So 49 plus 13 is going to give us 62 minus 14 square root 13. For 27, we are going to FOIL this one. So we're going to do 6 times 5 is 30. 6 times negative square root 3 is negative 6 square root 3. Then square root 2 times 5 is 5 square root 2. And square root 2 times negative square root 3 is a negative square root 6. We don't have any like terms here, and we cannot simplify any of these radicals, so we just leave it 30 minus 6 square root 3 plus 5 square root 2 minus the square root of 6. For 28, same thing, we're just going to FOIL. So 7 times 2 is 14. 7 times negative 7 square root 5 is negative 49 square root 5. The negative 3 square root 2 times 2 is negative 6 square root 2. Negative 3 square root of 2 times negative 7 square root 5 is going to give us a positive 21 square root 10. So once again, 21 square root 10, there we go. So once again, we don't have any like terms, we can't simplify any of these radicals, so we just leave it. For our last section, we are rationalizing these denominators for these fractions. So remember, taking the conjugate of our denominator. So if we look at 29, 5 over 3 square root 5, the conjugate of the 3 minus square root 5 is 3 plus square root 5. So we're going to multiply the top and the bottom of this fraction by that conjugate. So we're going to distribute in that 5 to get 15 plus 5 square root 5 all over the 3 times 3 is 9 minus the square root 5 times square root 5 is the square root of 25, which is just 5. So again, this is a difference of squares here, so those radicals are going to cancel out. We're just going to have a squared minus b squared, which is where I got the 9 minus 5 from. 9 minus 5 is 4, so our final answer for this one is 15 plus 5 square root 5 all over 4. For 30, we have a little bit more of a difficult fraction here, because we have binomials containing these radicals on both the top and the bottom of our fraction. So we're going to take the conjugate of our denominator. So instead of it being 2 plus the square root of 7, it's going to be 2 minus the square root of 7. And we're going to multiply each the top and the bottom by that 2 minus square root of 7. We are going to FOIL. So 1 times 2 is 2. 1 times negative square root of 7 is negative square root of 7. The square root of 3 times 2 is 2 square root of 3. And the square root of 3 times the negative square root of 7 is negative square root of 21. All over difference of squares. So 2 squared, which is 4, minus the square root of 7 squared, which is 7. From here, top, you can't simplify that, so leave it. 2 minus the square root of 7 plus 2 square root of 3 minus the square root of 21 all over negative 3. You cannot leave a negative in the denominator, so in order to turn that negative 3 into a positive 3, you're going to have to change the sign on everything on the top of your fraction. So this is going to switch to be negative 2 plus the square root of 7 minus 2 square root of 3 plus the square root of 21 all over 3.